Hey everyone, welcome back. In the last lesson, we created our player pawn, we set up our controls using an enhanced input, and built a function to rotate our ship like a compass needle. Now, your ship can point in any direction, but it's still stuck in the center of the screen. In this lesson, we're going to build the propulsion system. We'll learn how to take the direction the ship is pointing, multiply it by the thrust speed, and translate that into actual forward movement across our deep space mapping. Now, to make our ship move, we need to understand a tiny bit about game math. A vector in game development is a data type that holds three numbers representing an x, y, and z coordinate. Vectors are used to describe a point in space, or more importantly, for us, a direction. Now, the getActorForward vector, this is a built-in Unreal node that looks at your ship's current rotation and calculates exactly which way its nose is pointing. Its output is normalized, and the direction vector, which means it represents a line exactly 1 unit long, pointing straight out of the front of our ship. All right, so now that we got some definitions out of the way, let's get back to Unreal and set up the thrust input action. Just like we did with turning, we need to create a new control action for hitting the gas pedal. So let's go down to our content browser at the bottom of our screen. And if you recall before, we have a folder called input. Let's select that. Right click in the empty space, hover over our input section here, and then select the input action. Name it IA thrust, and then let's go ahead and open that up. All right, so let's look at the details panel. And we want to leave the value type set to digital bool. And as a reminder, just for short, bool is short for boolean, and it's a data type that can hold only one of two values, either true or false. And because hitting the thruster in a classic arcade game is like an on and off switch, you're either holding down the button or you aren't. So a simple true false checkbox is perfect. So let's save and close our thruster here. All right, so let's go ahead and map our thrust key. So we'll open up your content drawer and then look for your IMC Asteroids controller and double click that. And then let's look at this detail panel. We want to click the plus icon next to mappings. So if you recall up here, and here's our mappings. And this time we want to click the drop down arrow on the new mapping and select IA thrust. I'm going to scroll down, see if we can find that. There it is. Now for this particular one, I'm not going to have the ship go backwards, and I don't think it does in the traditional Asteroids game either. So I'm just going to use my W key to have a forward movement. So let's go ahead and click on our select the key value. Remember, this automatically will input it, and I'm going to press W, and that should already do it. And as I mentioned before, you can click down here, go to keyboard, and you can find it. But I have pretty good luck with just selecting this and going with the W there. Let's go ahead and save this, and let's close our mapping context. And I tend to close them out and then reopen them later just because it makes it less cluttery, my interface. All right, let's go ahead and build the apply thrust function. And just as a reminder, I'm going to close my rotate ship function here. One of the big reasons why we use functions is because we want to keep our graph tidy. We don't want to deal with spaghetti code. So we put all of our movement calculations inside of for this particular case, a brand new dedicated function. So let's open up or make sure that it's open our BP player ship here. And then on the left-hand side of the blueprints panel, go ahead and click on the function section and look for this little plus sign here. And then this function I'm going to name apply thrust. Now what's really cool about this is if we look at our details panel here, we actually do not need any inputs or outputs for this because it will read our ship's direction data automatically. So all we're really going to do is write the movement logic. So inside of this empty function, locate your apply thrust node here or entry block, and let's wire up the propulsion machine for our super awesome ship. So let's right click in an empty space, and I'm just going to type get actor and then forward. And what I want is this get actor forward vector, and I'm going to select it. This node tells us exactly which way our nose, like the cone of our ship, is pointing. So let's drag a wire out from the yellow output of that node and just type in asterisk. So this is out of the return value. And we've done this before. We're just going to select our multiply node here. Okay, so let's go ahead in our variable section, click the plus sign, and let's add a variable for thrust. And we'll make this of type float. Make it public as well. Let's compile and save this. And for the value, just leave it at 25. Now, the reason we're going to use a thrust variable is because A, it makes it a little bit easier to control all three values. Otherwise, we'd have to go in here and type 25 for each one. And with this, it allows us to control all three at once, as well as when it comes time to, it gives us a little bit more control. Now, if you do something like this and you want to clear it out, when you drag your thrust in and you wire it in, it'll clear it out. But you could also right-click on this little pin here and just set reset to defaults. So let's wire this in, something like this. Next, let's right-click and do Add World, Add Actor, World Offset. And then just wire this into our execution pins and then wire this value into delta locations. So what this add actor world offset node does is it doesn't apply any rotational math. It just takes a raw direction vector and pushes the ship forward. So because our actor's forward vector node here is already doing the heavy lifting of calculating the angle of which way our cone nose is pointing, the world offset simply executes the direction that it's going in. So that looks pretty good. Let's compile and save it. Now there's also another issue. Wherever I start the camera off and I press play, you can see that my ship spawns in the center of the screen. I always want to have a default place for my ship to spawn from. So inside of our outline over here, take a look as we click here and then we just go to basic and we add a player start. And I'm going to restart it down in the details panel at the bottom. I'm just going to go ahead and enter 0 for each one of these values. And then I want to raise it up a little bit on its z-axis. Let me hit F to focus so you can see how it's cutting through, and you're getting a little sign here that says bad size. I want to drag it so it's not cutting through the ground plane, and then it should turn into a controller, and then you know you're okay. And I'll save that. And now when I press play, it'll always spawn at that location. And when I press my W key, I should be able to move. And if I hold W down and I push A or D, you can see I'm rotating. So it looks pretty good. I'm going to go ahead and hit escape from there. And this tutorial ran a little long, and I hope you enjoyed it. And yeah, I think in the next section we're going to learn about loops, programming concept called loops, and we're going to take a look at maybe creating a procedural asteroid system.